Hello class, welcome to our discussion for today. This time we are going to combine what we have learned from higher order derivatives and also on our discussion of the derivative of trigonometric functions. Okay, so before we go to the combination with the higher order derivatives and with the trigonometric functions, let us review first some example here. We have f of x equal to 3x to the fifth plus 2x cubed minus 6x plus 4, and you are asked to find so this is the given. For example, this is the given, and you are asked to solve for the secant derivative. You're asked to solve for the f double prime of x. Okay, so how will we solve this problem? Right, so from our given f of x, so from there, so f prime of x is equal to, so we'll apply the power rule and differentiation. We have of course we have the constant 3, then from the power rule, so we have 5x to the fourth, right? Then plus 2 times power rule, 3x squared, then minus 6 times derivative of x is 1. Okay, so f prime of x is equal to, so this is 15x to the fourth and plus 6x squared minus 6. Okay, so we're done with the first derivative. Now let's find the secant derivative. Okay, so the secant derivative is just the derivative of the first derivative. In other words, f double prime of x is equal to, so again we have 15 times using the power rule, so 4x cubed, and plus 6 times, again power rule, 2 times x to the power 2 minus 1 is 1, then plus, or this is minus 0 here. Derivative constant is 0. Okay, now we have f double prime of x is equal to, this is 60x cubed and plus 12x. Alright, so that's our first example. Just to recall what we have in higher order derivatives. Now in our next example, we're going to combine. Now, for example, if you're given, say for example, you're given if you're given h of x equal to x squared times cosine x, and you are asked to find the, okay, so this is the given, and we are asked to solve for the secant derivative, h double prime of x. So how will we solve this one? Now if you look at the given class, so we have here a product, no? We can use this as our u, okay, and we can use this as our v, and then we'll use the formula. If you can still remember, you have derivative of derivative of the product f and g, okay, with respect to x. So this is equivalent to f prime times g plus f times g prime. Alright, or if you can still remember, we have, this is the same as derivative of u times v. I think we used this in our previous example. And you have u times derivative of v with respect to x plus v times derivative of u with respect to x. So you can use either of these two formula. They're just the same. Okay, so our solution here, so using this as our u, okay, so assuming this is our u, okay, so assuming this is our u and this is our v, then let's try to use this, or if you want to use this one, it's okay, no problem, they're just the same class. Okay, so I prefer to use this one. Alright, so h prime of x is equal to, so it says u, you just copy u, so you have x squared, then times derivative of times derivative of v, so this is our v, so derivative of cosine x, right, with respect to x, then plus so plus v, so what is our v? Okay, so our v is equal to cosine x and times derivative of u, where our u is x squared with respect to x. Okay, so this is equal to x squared multiplied by derivative of, what is the derivative of cosine, class? So we have a formula, derivative of this derivative of cosine u, cosine u with respect to x, equal to minus derivative of sine u times derivative of u with respect to x. So we will use that formula also. So we have, for this part here, derivative of cosine x, so we have to use this formula. So this is minus, so negative, but this is multiplied with x squared, so negative sine u is x, alright, times the derivative of u. What is our u? So our u here, this is our u, okay, for, so the x here is our u. Okay, so derivative of x with respect to x, then plus cosine x times, so applying the power rule, so that is 2 times x times the derivative of x with respect to x, so equal to, so this becomes minus x squared sine x, so negative, no? Negative times positive negative, then derivative of x with respect to x is equal to 1. Okay, so derivative of x with respect to x is equal to 1. We also have here derivative of x with respect to x equal to 1. Alright, so what is left here is this one plus we have, so multiply this one first, or write it first, 2x times cosine x, or rearranging, so we can write this as 2x cosine x, then minus x squared sine x. Okay, so we're just done with h prime of x, but we are asked to solve for h double prime of x, or the secant derivative of the function. So here you can factor out common, but let's just retain this expression as this one, so that we can proceed to the next steps, no, in finding the secant derivative. So now this is also a function. Our first derivative is a function of x, so we can now solve for the secant derivative. So the secant derivative of the function, so we have here we have two terms. So our terms composed of a product. Okay, so this is composed of the product. Okay, so we will use again the product formula. So you can use either this one or this one. So we'll do it twice, no, for this one. Alright, so we have this product, we have another product here. Okay, so and be careful of the sign. Alright, so to continue applying this rule, so in this case this is our this can be our u, and this can be our v. Here this is our u, and this is our v. Okay, so using the product rule formula, so we have u, so u times, so u means 2x times derivative of this v, derivative of v. Our v is cosine x, so derivative of cosine x with respect to x, then plus v, our v is this one, so you rewrite that one, so cosine of x times derivative of u, our u is 2x with respect to x. Okay, so this is only for this part. Then minus, so to avoid any mistake, so minus, since the resulting product here is composed of many terms, so we have to enclose this with this one, a parenthesis or a bracket, just to make sure that the sign negative will be considered. Alright, so again using the product rule, so we have our u is x squared times the derivative of v, which is sine x with respect to x, then plus v, our v is sine x times the derivative of u, our u is x squared with respect to x. Alright, so equal to using the formula for derivative of cosine, so derivative of cosine is minus sine, so 2x times derivative of cosine is negative sine of x times, using the formulas, derivative of cosine is minus sine, derivative of cosine u equal to negative sine u times derivative of u with respect to x. So in this case, for this part class, this is our new u. This is our new u. This is our u. Okay. Similarly here, this is our u. Alright, so derivative of x with respect to x, then plus cosine x. So using the constant multiple rule, derivative of 2x with respect to x is just, by the way, we have cosine x here, times derivative of 2x is equal to 2. Okay, so minus x squared times, so we also have the formula for sine, derivative of sine u, derivative of sine u with respect to x is equal to cosine u times derivative of u with respect to x. Okay, so we'll use this formula here, this formula for this part. Okay, so derivative of sine, which is cosine u, or u is x, times derivative of u, which is x with respect to x, then plus sine of x, then times derivative of x squared with respect to x, so power rule, so we have 2 times x. Okay, 2 times x, so derivative of x with respect to x. So again, if you will see this derivative of x with respect to x, that is always equal to 1. So this is equal to 1, this is also equal to 1. Okay, so this is positive times negative, this is negative, negative 2 sine x, then times, or sorry, plus 2 cosine x, then minus, we have x squared times cosine x, then plus, we have 2x sine x. Now removing the sign of grouping, this one, let's remove this bracket, so minus 2 sine x plus 2 cosine x minus, so you have to multiply this negative for its term, so this becomes negative x squared times cosine x, then positive times negative, so that is also negative 2x times sine x. Alright, sorry class, we missed something here. So here we have supposedly have x, so we also have x here. Okay, so this is 2x. Now I will rewrite this, so this is minus 2, sorry, so this is minus 2x sine x, and then plus 2 cosine x minus x squared cosine x minus 2x sine x. Now combining similar terms, so we have similar terms here. We have negative 2 sine x, negative 2x sine x, and we also have negative 2x sine x. Alright, and then writing it first, this one, so we have 2 cosine x minus, so when you add the 2, so this becomes minus 4x sine x, then minus x squared cosine x. Alright, so this is our h double prime of x. Okay, so this is our answer. Alright class, so we have combined higher derivatives and the derivatives of transcendental functions, specifically trigonometric functions. So I hope you were able to follow how this problem is solved. Alright, so if you have no question, then you may proceed to solving another example, another exercises class that I will be giving you later on. Okay, so thank you for watching and hope to see you again in our next video. Stay safe always and healthy always. God bless. Bye.